Hello everyone, good afternoon. Welcome to today's webinar on best practices of managing a large project on BIM. Thank you so much for dialing in for our webinar. I hope all of you can see my screen. First, let me introduce myself. My name is Niriksha Devadiga. I am associated with Desapex as a project engineer, and I will be responsible for hosting this webinar today. I would also like to introduce today's speaker, Mr. Santosh Gaurav, associated with Desapex as a digital design manager. Hi, Santosh. Welcome to the webinar.
Hello, everybody.
So before going to start the webinar, I would like to brief you about the agenda of the webinar. I will be introducing you about Desapex, and Santosh will be telling you why do we need BIM for any project and the desired use cases of BIM in a project. He will also brief you about the framework standards for BIM in a large scale projects and the BIM workflow on large scale projects. He will explain to you about the prerequisites and considerations of implementing BIM in a project. And he will also give you a general advice for the built industry. So let me introduce you to Desapex. Desapex is a digital engineering organization working towards digital technology integration in the AEC industry to improve the life cycle of built assets. We provide complete digital solutions throughout the life cycle of the building or infrastructure, that is design, construction, and operation. Desapex aims at creating a sustainable built environment by enabling digital adoption and integration of technologies for target value design. So we are headquartered at Silicon Valley of India, Bengaluru, and also we are operating from 3 major cities in India. Those are Chennai, Hubli, and Hyderabad. We are serving all over India and also have customers across the globe. These are some of the customer segments which we are serving, starting from hotels and restaurants, cooperative real estate, residential, etc. We can give digital solutions wherever there is a capital expenditure and operational expenditure involved. So the construction industry is facing lots of challenges in this digital transformation era. Majorly poor productivity is because of poor coordination between stakeholders and designers. Complications arising midway during construction will decrease productivity. 2D drawings can cause miscommunication between the stakeholders, and it is very difficult in rich visualization content such as animation, rendering, etc. Running a project without good project management is a false economy. So it often leads to an unnecessary burden on the budget. If the facility data is not properly transformed to the client at the time of handover, and the data will be lost with the passage of time. This will cause difficulties for retrofitting and renovation in future. Lack of standards and regulations can result in the tragedy like structure collapse, fire breakout, and general deterioration, etc. Sustainability can be one of the most challenging aspects of this industry, as construction industry contributes 11% of world's greenhouse gas emissions. I would like to brief you about the digital solution which we are providing to our clients, which are the 3 verticals of Desapex: digital design management, digital project management, and digital asset management. So under the digital design management, we provide the solutions for clash detection and coordination, including architecture, structure, mechanical, electrical, plumbing, firefighting, modeling, and BIM-based pre-construction services. So we manage the design under the digital framework for the designs which are already authorized by the consultants. Under the digital project management, we are providing our clients to manage their construction projects digitally, where we provide a digital information delivery plan, technical due diligence, and setting up a digital lab. Coming to the digital asset management, here we assist our clients to digitize their project document in terms of the latest as-built 2D drawings and 3D BIM models. And also we digitize the existing physical building, like the buildings after the handover stage or during the operational stage. We are partnered with Finnish company Grenland to provide the solutions like BIM for facility management, in which we provide maintenance management, energy management, asset management, and also real estate portfolio management services using the BIM model. For that, we have a special software called Grenland Manager. Digital twin is a virtual replica of project. Here we build models by using laser scanning technology. That is nothing but we are going to develop BIM model using reality capture data, and that model can be further used for as-built verification and documentation. So let's go through some of the case studies of our projects where integration of technology and digitization provided great outcomes to our clients to meet desired results. So in one of our projects, we have developed a BIM model and produced drawings for one of the biggest malls in Malaysia with an approx area of 10 million square feet. So the building had 14 services that were to be coordinated, and the coordinated layouts were produced as per the client requirements. The team was highly enthusiastic and hardworking towards every deliverable. Finally, the coordinated models and layouts were delivered with utmost quality and standards. We have worked as a BIM consultant for a leading electronic manufacturing company with multiple buildings for approximate area of 600,000 square feet. We coordinated with various stakeholders and made sure all the services were clash-free with supporting elements for a LOD 400. Then the site is scanned with the laser scanners after the erection of all the services, and the model will be updated to LOD 500 as per the site condition. As well as the same model is used for facility management services. The scan-to-BIM solutions we have provided for an ongoing commercial building of a banking sector with an area of 800,000 square feet. As DDM consultant, we also checked for site deviation in structural and firefighting layouts for as-built model coordination with upcoming building services. Digital solution for virtual walkthrough of the same ongoing project were also provided for progress reporting purposes. We have developed a team capable of integrating design and construction parameters into a digital information modeling, which blends the expertise in domain, process, and tools, and also provides the owner an unmatched performance. This is our approach to deliver quality projects on time. This is our young, passionate team, and we have civil, mechanical, architecture, and BIM engineers, which is under the leadership of Mr. Srinidhi and Mr. Varun Kumar. This part is the USP of Desapex. I feel very proud to say that we are the first company in the world and only company in India to have this Kitemark from the British Standard Institute, which is a global standards for BIM, and it is ISO 19650 part 1 and 2. This is all about Desapex portfolio. Now, I would like to hand over further session to Mr. Santosh. Over to you, Santosh.
Thank you, Niriksha, for your introduction. I'll just share my screen. Hello, Good afternoon to all the participants from India, and good morning and evening to all the people from other parts of the globe. I am Santosh Gurav. I am associated with Desapex as the Digital Design Manager, and my role is to look after the overall project management and its delivery. So let's have a look at today's session contents. The first one will be focusing on why do we need BIM for any project. Then we'll define few desired use cases of BIM in the project. Then moving on to the framework which is required for BIM on the large projects. We'll define few standards and explain them that are required for BIM in the large scale projects. Then we'll move on to the BIM workflows. And then we will let you know few prerequisites and the considerations for implementing BIM in the project. At the last, we'll have some general advice for the built industry based on our experiences. Before we jump on to these topics, we request the participants to take the 10 seconds to let us know their professional backgrounds so that, just to have a feel of the audience. Let's start the poll. Awesome. These digits look great. Thank you. So moving on to the contents of the webinar. Why do we need BIM for any project? The big why before we initiate anything. We are all aware that the AC industry is one of the least advanced industries in terms of productivity and technology adoption in the world. The decisions that we take in a project are mostly reactive, and we think too late about most of the things. We use different tools, but rarely get the maximum potentials out of them. The information that we create is often in an emergency because we all are aware somebody has unexpectedly realized he needs something to be delivered by yesterday. And the requirements tend to be unpredictable. We all have been through the stages where a client changes mind in terms of the deliverables in the middle of the process. Like Niriksha explained in her presentation, the challenges involved in the large projects are many. I have noted a few major ones out of the many. They are the long duration, large scopes, too much of rework, unstructured communication protocols and confusions, which are the major, lack of quality documents and unstructured documentation, change orders, schedule conflicts, out of sequence work, complex interfaces, significant requirements for management, and at the last, complicated coordination and cooperation. Generally, in a large project, take it might be a public or a private, the stakeholders involved are from all over the globe, from different continents, practicing different methods and processes for delivery, working in different time zones and even different cultures. This is why we need a process, a methodology to get all the things towards a unified approach in order to get the right data from all the stakeholders so that we have a common language structure, which is the key when we exchange information and the data is being collected to a single place. And that process is BIM, and that is why we need BIM for any project. So moving on to our next content, defining the desired use cases of BIM for a project. There are a lot of use cases of BIM which can be implemented throughout the project lifecycle, starting from the planning and the design, in which we can model the existing conditions, carry out site analysis, design reviews, etc., to the procure and construction stage, where we have phase planning, digital fabrication, laser scannings, etc. And at the last, the operational phase, where we can have the as construction modeling, asset documentation, and so on. As said earlier, there's a whole lot of use cases of BIM throughout the project lifecycle. I will try to get in depth for a few of them. Existing conditions modeling. Understanding the existing condition provides the project team with a framework for evaluating an existing facility and its system. When the design documents of the existing conditions are not available, the team may need to utilize other means of modeling these conditions. Techniques employed for documenting existing conditions may be laser scanners to point clouds, it might be photogrammetry, the exterior UAA photography, and manual field verifications. The majorly used one is the laser scanning, which saves countless hours of error-prone field measurements and often captures far more information than the traditional methods. The next case use which jump on is the design review. Tools that utilize the BIM data allow the project team to validate design decisions through both quantitative and qualitative analysis, as well as a collaborative review. The design data will also be shared in the meetings with the facility users and all the stakeholders involved in the project to encourage feedback on important aesthetic and functional elements of the design. The next use case is the 3D coordination and clash detection, which is one of the majorly used use cases of BIM. Unlike traditional 2D drawings, use of BIM can allow the design team to employ a managed approach to the advanced collaborative reviews, including automated element collision detections. By coordinating BIM data during the design phases, this can reduce the number of potential major conflicts that might arise during the construction phase. This approach is not meant to replace the traditional quality control process, but it should enhance the ability of the project team to visualize the design and detect interferences between discipline components. The next use case is the drawing generation. Using BIM enables a more coordinated approach to the creation of traditional construction drawings. In addition, the BIM allows the team to generate enhanced documentation that more realistically represents some of the most complex details of the design. Examples might include like 3D detailing of important elements such as continuous exterior expansion joints, or might be some waterproofing components and customer intercabinets, etc. The next use case is phase planning, or we generally call it as the 4D modeling. Because BIM can capture phased information throughout a facility's lifespan, it is ideally suited for communicating long-term how a project may be constructed, occupied, maintained, and eventually renovated for reuse. Using BIM allows us to graphically communicate the sequence of renovations in both time and required actions, so that everyone has an understanding of how various people and departments will be impacted during each phase. The next use case is the asset management. The facility managers have been doing asset management for years without using the 3D virtual models. So why would an owner or facility manager be more interested in a 3D virtual models which are intelligent? Let's consider the traditional project handover package delivered to a facility manager from the design teams and the construction firms. This package included boxes upon boxes full of paper documents, CDs, and USB drives, which contain all the information which is vital for the functioning of the building. This could range from the maintenance schedules, list of warranty expiration dates, and the location of the lighting fixtures, power devices, etc., and so on. With the advent of BIM technologies, the building manager can now utilize a fully intelligent 3D design model to make sure the building is functioning properly today, as well as 20 years into the future. This is all thanks to the seamless integration of building information into a single source, which is the model. When provided as a fully accessible closeout package, this can transform the facility management. Next, we'll have a look at the framework of BIM for the large-scale projects. The framework is largely built on three pillars. These are the people, the process, and the tools. The people are the most important part to the project than any tools or processes. They are made up of different skills like the leadership, collaboration, engagement, and they even have responsibilities. They also have different roles in the construction, such as the modelers, the designers, the project managers, the BIM managers, content creators, and so on. Things to be considered in terms of people are the culture in which they work, the organizations with which they are associated, and the trainings they undergo on regular basis, which consist of two parts. The assessments consist of the skill metrics and the skill focus, which consist of the standards, workflows, and the maintenance to be implemented by the people. The next pillar is the processes. Process is the means by which we deploy tools and is invariably more important to the success of the project than any other. Process on a broad level include the BIM project execution planning, which explain how in BIM deployed in the project. The next one is the collaboration workflow, which explain how and when do we share the data effectively. And next is the standards, which explain how does every resource involved in the project know the proper formats of the deliverables and likewise. The process also include the information management protocols, procedures, data creations, content approvals, etc. The next pillar is the tools. These are made up of hardwares and softwares and the network. We all are aware of this. The hardwares, which consist of the servers, workstations, where we need to decide what capacity of performance of the hardware is required to execute the project efficiently, and the softwares, which include the applications, the data files, and the parameters, etc. and so on. The next part, the network. This refers to the internet or the network connection of an organization. This depends where are the project teams located and how are they connected and how we can maximize the bandwidth and minimize the cost. Up next, we have the standards for BIM in a large-scale project. The ISO 19650 standard, which is the international standard for information management. It is defined as the organization and digitization of information about building and civil engineering works, including building information modeling, BIM. In short, information management using BIM. It has 6 parts. The part 1 explains the concepts and principles. The part 2 is for the delivery phase of the assets. And the part 3 is for the operational phase of the assets. The part 4 stands for the information exchange, which is still under development. The part 5 is for the security-minded approach to the information management. And last but not the least, the part 6 is for the health and safety, which is still also under development. This 6th part for pre-construction and construction stages. Next, let's look out for some ISO standards for BIM information exchange. The first we have the ISO 16739, which is the industry foundation classes, or we generally call it as the IFC. Next we have the ISO 29481, which is the BIM information delivery manual. And then the ISO 12006 part 3, which is the framework for object-oriented information. We have to remember that the ISO 19650 standards or the International BIM framework do not speak about which type of design has to be undertaken or anything related to the design codes. Its area of influence is exclusively on information management. that is BIM models with geometric and non-geometric information, validation of quality and quantity of information, document how, when, and between whom the data exchange will take place, and the common data environment for accessing the project documents and defining the structured way of storing and managing the project documents. All of these factors driving towards bringing more transparency to the owner's expectations and the deliverables by the service provider, and also ensuring all project protocols are visible to all the stakeholders involved in the project. BIM framework and standards are developed also to go hand in hand with other popular project management practices around the globe. Next, let's move on to a few of the BIM workflows for a large project. Please bear with me as this section is the heart of the webinar, and if you guys are feeling drowsy after lunch, this will surely wake you up. Until now, we saw the importance of BIM implementations, the different standards and frameworks, etc. Now, let's explore how this can be applied to a project's life cycle and how the digital processes, tools, and technologies will be utilized to bring the best of your BIM experience. As seen before, we have construction professionals from different backgrounds participating in this session through our poll. This section of the webinar will be relevant to all and provide insights on how you can adapt this into your next project workflow. As with any building or infrastructure, it begins with the owner, or the so-called appointing party as per the terminologies of ISO 19650, who has the notion of building its new place of operations. In the initial programming state or assessment and need, as per the ISO 19650, the BIM framework requires the owners to document the organizational information requirements, project information requirements, and asset information requirements, which are acronym to OIR, PIR, and AIR. To make sure the project being undertaken is meeting the organization goals, the ISO 19650 framework recommends appointing a dedicated capable team to carry out the overall project's information management. It could be the internal team of the owners, or they could hire an external team that might perform the required tasks. The owner prepare this list of requirements based on what the building should contain with respect to the type of space, size, and other amenities. How he intends to process the project's tendering stages, desired project delivery methods, etc., just like a traditional method. In addition to this, in the BIM framework, the owner is required to define the scope, set up the storage platform, which is the common data environment, the CDE, the expected milestones, what softwares will be used to generate the information, the data exchange format, and how the overall project's information management process will be undertaken, and also a detailed responsibility matrix and an acceptance criteria, and the level of information need, the LOD and LOI, and also the intended use cases of BIM, which are many, like whether BIM is being used for just the geometric 3D spatial coordinations, or the rendering and visual representations, digital fabrication, or might be the last stage of facility management, wherein the COBie data is fed into the model, and so on. All of these things are compiled as information requirements and are to be adhered and practiced by the prospective project construction team, which include the consultants, contractors, and the FM teams. The exchange of information requirement, or the EIR, becomes a part of the contractual document for the owners, because this ensures that all the stakeholders involved in the project are bound by the same protocols, and unified information management will take place throughout the project cycle. If the owner has multiple projects in his portfolio, this will be a great benefit, as they can incorporate the same protocols for the upcoming projects to ensure a streamlined project management, benchmarking, and also the cost templates. Now, the next step would be to compile the technical system requirements, any special requirements, project timelines, EIR, the contract documents, anything else, all of this will be clubbed and compiled to an invitation to tender, which we also refer as the RFP. It will be prepared for all the prospective architects, engineers, and other consultants to apply and respond to the EIR, which is the information management requirements, along with the other contractual requirements. The response is sent by all the interested consultants to the owner, highlighting the EIR sections that are possible by them, not possible, if they want to amend certain modifications in the requirements that they received. And the document for this will be called as a pre-appointment BIM execution plan, or you call it as pre-BEP. This will be detailing how the service providing organization intends to deliver the project scope in accordance with the EIR, BEP, quotations, and the other contractual documents, which will be the part of the tender response. They will also include the risk register if they foresee any risk in the current RFP scope, and also a mobilization plan. The owners reviews the tender responses, BPs, and other documents from all the bidders. And based on the acceptance criteria that he has set, he selects the best bidder who suits for his needs and appoints a bidder for his project. This service providing organization is called as the appointed party as per the ISO 1950 terminology. Likewise, multiple appointments happen based on the requirements of the project and based on the division of the scope planned by the owner. Now the appointed parties, design consultants, submit the post-BEP responsibility matrix and the master information delivery plan to the appointing party, which is the owner. And after mobilization, they will move on to the next step, which is the pre-construction stage, wherein the design teams are producing information collaboratively as proposed in their BIM execution plans. The delivery team performs data exchanges in the project's common data environment, which consists of all the project stakeholders involved in the project. As documented in the EIR and BIM execution plan, file naming conventions are strictly followed, and the predetermined approval processes for all the documentations are adhered to using the acceptance criteria, QA/QC methods, and the checklist. Weekly virtual design reviews, or the VDRs, or in general we call it as the coordination meetings, will be organized to track the project progress, manage the critical constructability issues, design changes that may be required by the owners. The coordination issues with other design consultants will also be managed based on the tolerance and coordination guidelines set by the owner. Any change that is made in the design revision will also be documented and processed as per the change management system set out in the BIM execution plan and the EIR. In the ideal digital environment, BIM will be used in augmented reality and virtual reality form to make better informed design decisions and resolve conflicts. Making use of GIS survey, accurate data can be captured and BIM can be developed with more accuracy. This allows the owners to reduce surprises in the field. A well-coordinated model with all the services like the civil, architecture, map will greatly enhance the productivity during site installation, and it will also reduce the material and the time waste which results due to the rework and lack of coordination. Using BIM, owners can design and compare design options and also the LCA, which is the life cycle assessment, to identify the most sustainable design by enhancing the material and its selection process. BIM can eventually help You quantify the sustainability parameters to make your building more environment friendly. Prior to proceeding with the construction and finalizing the construction cost and time schedule, the owners can make use of the latest tools and technologies that allow them the 4D, which is time, and 5D cost simulations. This helps the contractors, owners, and the design consultants to visualize the project progress in terms of the building construction. The contractors can use the same digital three-dimensional Gantt charts for their construction activities. The owners can now allocate and reserve funds and cost required for the specific time frame, and all this can be documented for the internal management approvals. Following the design finalization or the information model delivery, the owners proceed to the construction phase, which is done after the submission of the information model delivery. At this stage, again, there will be a tender bidding process to onboard the contractors for constructing the design building. Similar to the initial appointments, what you saw in the design construction phase, EIR tender documents, which now consist of the BIM models, drawings for supporting the construction activity, will be shared with the prospective bidders to submit their quotations. Again, the BIM execution plans, codes will be submitted by the contractors for the owner's review and approval. Once the contractors are on board, they will produce the shop drawings, the EHS, they'll go for their model approvals, create schedules, materials and technical data sheets, and all of this data will be submitted in the form of BIM models or any other approved processes. In certain cases, digital fabrication using BIM models can be performed. To monitor or check the construction site progress, the owners can make use of laser scanning technology to scan the building according to a routine schedule and compare it with its building's 4D and 5D simulation plans to see if the building's expected schedule is being met. Not only schedule, this also helps in the terms of documenting stage-wise milestone of the building and preparing the progress reports for the building owners and senior management personnel or any other relevant stakeholders who cannot attend the regular site meetings, especially during this pandemic. They can make use of the accurate and the detailed building scan data. Another great advantage of BIM and the as-built scanning is that you can compare the actual amount of materials consumed and the work status. Also, this data can be used for the vendor bill certifications and the purchase order approvals. Proactively, and potential risk that may occur can be documented using a risk register. The owner, contractors, and the engineers can collaboratively list the potential risk they foresee and plan risk responses to address this risk and reduce the impact of the risk when they actually occur. With the help of routine coordination meetings, implementation, proper review process, and construction progress monitoring, and also the accurate as-built model updation using scanned data, the construction phase can be completed with minimal waste of materials and time and cost overrun. After the construction, the contractor needs to submit the as-built BIM model, which is enriched with the level of information need, which is defined prior in the BP and in the EIR, with all the relevant other data of the COBE and facility management, also including the technical specifications, all embedded into the BIM model and hand over it through the project closeout. After the closeout or the handover, the owner's FM team can integrate their CMMS system with the state-of-art tool like the Grandland Manager that allows them to make full use of the BIM capabilities. Documenting and tracking the service request, energy consumption data, and over energy management had never been this easy. Integrating your BIM model with your O&M manual, you can easily digitize the property management processes, increasing the productivity and the efficiency in terms of cost and time saved in resolving these issues. Continuously, using the BIM as a model and the other O&M data gathered, you can refer to this building's performance and benchmark certain parameters to compare with the other buildings in a portfolio. Documenting the lessons learned and the feedback from other stakeholders, the risk involved, the problems, and the issues that occurred in different stages of the project, we can ensure this does not happen in the future projects. This is the key step in the closeout of the project as mentioned in the ISO 19650 framework. Now this ends the BIM workflows. Moving on to the next content, let's have a look at the prerequisites and considerations for implementing BIM in a project. The BIM requirements must be clearly articulated in the contracts. For many of us, BIM represents a new way of collaboration, and we share more information both across the disciplines and the phases. Excuse me. With this big change in how we do things, we need to update our contracts to ensure the new way of collaboration working is a success and not to prevent falling back to the old way. Next, implement the international standards in the contract at the early planning stage. The project should not use just a template without filling out the extra information or adjusting for the project specific criteria. An example would be, do not just mention a sentence saying BEP should be as per the ISO 19650. Instead, define the requirements clearly. Setting the correct expectation level of executing BIM. There may be a perfect way to do BIM, but instead one of the true ways we need to define the right way for our projects. This can be done by setting the correct expectation levels. BIM can be an enabler of great things instead of a barrier for the project participants if we set the expectation levels correctly. The level of information need, the roles and responsibility metrics of different professionals involved, clarifying their actions and responsibilities, and specifically the relationship of dependency between their tasks. All of this give out the correct delivery expectation for all the project stakeholders in the project. The next is the owner needs to specify the requirements for the use of BIM. This is not on a broad level practice into the industry, so we are majorly highlighting on the owner's side. The implementation should start from the day one of the project. The project owner or the asset owner is the overall responsible for the requirements, as they are the one who will cover the cost of the projects. The owners need to specify the requirements for the use of BIM, as they have a responsibility for future-proofing their assets and in defining the ambition level and risk tolerance of the project. However, the owners do not have all the answers. The BIM requirements are better handled by the project team themselves. They are the architects, the MEPF consultants, BIM coordinators, who will define the BIM process requirements. But still, at the end, the owner is still responsible for proper BIM requirements being in place at the right time. The use of BIM tools and BIM workflows. This plays a huge role in the BIM implementation. They have a huge potential to affect most processes in design, construction, and operation phases. Now moving on to the next content, we have few general advice for the built industry based on our experiences. Be clear and honest when specifying the requirements. We need to make sure the bidders understand the requirement. Trying to fool the other parties by adding tough requirements which might be unnoticed is not the start of a good collaboration. We are often seeing that owners do not trust the new processes, so they ask for new information and new processes without adjusting the traditional requirements. And so the end result is obviously the double work. I'd like to get an example over here. Owners read something online. I would say like it's the Kobe, and they say, I need to have Kobe. They write something in their contract requirements. It could be a paragraph related to the Kobe, but they are not at all prepared or planned to receive the Kobe data. They do not have a setup to use it. Then we are just asking, why do you ask for it? The next is, please do not copy the BIM execution plan from one project to another. BIM execution plans are directly being copied from one project to another, which is a major observation from my experiences. Again, without adjusting for the project specific needs or adjusting from the lesson learned from the originating project. Always strive for better solution. If either you or a contract party finds a better solution in the middle of the process than what is defined in the initial EIR and the BP, and you both agree the new solution should be easy to change the requirements and still you people be clear about your responsibilities, then please go for it if it's better solution. Design for and be prepared for changes and addendums. As the saying goes, change is the only constant, and we construction professionals have in-depth experience in these concerns. Every big project is a multi-year journey. You are going to learn things the way, and the industry is progressing quickly. Last but not the least, we'd like to have the conclusion. Very soon, BIM will not be an option, but a necessity mandated by owners and the government. We are already seeing many projects in India that are participating good BIM framework, both in public and private sector projects. Moving forward, every construction professional will be required to adopt digital tools and technologies and global standards for their project management so that they are sustainable in this ever-changing world. To support this transformation, Desapex has been working with various organizations to have a smooth transition from traditional to the digital practices. We hope this session has helped you gain a better understanding and a new perspective to how BIM can be implemented in your organization and the future projects. Similar to this webinar, Desapex has hosted many webinars before on various topics and will continue to bring more according to the needs of the industry. You can reach out to our team and get details of the previous webinars and can even request a personal demo if required. I would like to conclude this. Thank you for joining the session. Over to you, Niksha.
Thank you so much, Mr. Santosh. I hope all of you now have a brief knowledge on the best practices of managing a large project on BIM. So if anyone has questions, can drop their questions in the chat box.
We have one question coming in. Has this workflow hash best practices helped you guys in any project? Obviously, yes, in all aspects. That's the main reason we are sharing it with all the participants. Specifically, I would like to highlight one of the commercial projects in Desapex portfolio, which was from the Southeast Asia. It was around 10 million square feet, and our scope was minor to the project. But what the highlight of this was, there were more than around 20 design consultants involved during the design phase, which went on over for like I would say 2 years, and with 4 rounds of design submission package, one package for every 6 months. And every bi-weekly, there would be a VDR meeting for half a day where all the 20 odd design consultants would attend. And the ISO 19650 framework was set up by the owner's highly experienced infra management team in a very detailed manner, which led to the success of the project. The project's overall cost was estimated around 8 billion, and we can just imagine if there was no framework in the place for the project, the chaos it would have created from the design during the construction stage. Not just this project, there are, I would say, many projects in Desapex portfolio wherein we implement the 19650 framework. The entire workflow of our project is around the international framework, and that allows us to develop the maximum requirements, I would say, at the start of the project phase itself, as it just clears out what document to be created and I would say what information it should contain, and it also describes who has to produce the data, how the data is to be produced, and what is to be produced. And every stakeholder involved is also aware about the roles and responsibilities. I would say through this, all the confusion and miscommunication and other challenges are obviously eliminated. And we all are aware it's the miscommunication and the lack of centralized data which leads to the cost overrun and timeless exceeding during the construction phase. There's one more question in the chat. Did you work on any metro projects? Yes, we have, and that too in a very collaborated format with the international standards. You can get in touch with our sales team to get a personal introduction for that. There's one more. You spoke about using using scans to better BIM models. Can you explain that part? Do the scans get used to be as-built models or just to help the modeler make the as-built models? I would suggest based on the scanning and the as-built documentations, we have already done a webinar which has complete details. It was done, I think, some 2 months back. You can go through that webinar in a YouTube and you'll get a clear idea of what are the benefits and also the use cases of that. There's one more question coming in. Have you applied 3D laser scanning and BIM for facility management during the operation phase? Yes, we have been providing this service, and in my opinion, The biggest problem of applying BIM during the operation phase is the accuracy of the as-built models from the previous phases, such as design and the construction. With the help of laser scanning, we captured the as-built conditions and update the BIM models. If there are no BIM models available, then we develop the BIM models from the point cloud data.
Um, Thank you so much, Mr. Santosh, for sharing a very informative and valuable session. And I would like to thank each one of you for joining us. We will connect again soon and bring more and more interesting topics in our industry. So stay tuned with the Desapex at LinkedIn and at all other social media platforms. Thank you, everyone.